Bonjour, je suis Jean-Philippe Ancos de France.
Ciao, sono Mauro Benici dall'Italia.
Hola, soy Luis Beltrán de México.
Hej, ik ben Sammy uit België.
Cześć, tu Bartosz Polski z Polski.
Ciao a tutti, sono Francesca dagli Stati Uniti.
大家好，我是 Ryan，来自台湾。
And welcome back at the stream of the Global AI Developer Days. We're, again, I was going to say halfway, but not at all. But we're inviting another guest today, and that's going to be Aman Sharma. Hey, Aman. Good morning,
Hello.
afternoon,
Hi,
or
guys.
evening.
Hi.
How are you doing?
Hi, I'm doing great. It's actually afternoon, and I'm in middle of my office day and trying to sideline and do this session with you guys.
In
Great.
between the flamingos.
Yeah, that's a nice office wallpaper.
Aman, please introduce yourself. Who are you? Where are you from? And what do you do in your day-to-day work?
Sure, I would love to. So I think I would define more myself as a born hacker who tries to find solutions to problems. I originally come from India, and now these days I'm living in Singapore. I have been a serial tech entrepreneur trying to find business solutions using engineering and technology, what I have as my skills. And the whole triage for technology and data science or machine learning has been very early on from my career days when I started working as AI and machine learning engineer at Upsell. And then after that, a couple of few internships in other startups, I thought of like just going full steam and building my own startups. One of them did okay-ish, another one failed, and third one succeeded. And now I'm trying to do the fourth one. So let's see how it works out. And I would love to share my learnings as this session that is called Data Everywhere. No time to think. We'll talk more about this in the session.
Yeah. Well,
Great.
it's when I read the abstract of your session, it's like, this sounds quite interesting. So I'm really looking forward to your session. So with that, the platform is yours. If you share your slides with us, then everyone can see them.
Absolutely. I hope my screen is visible.
Yes,
Yes.
coming through.
Good luck.
Awesome. Awesome.
Oh, you're sharing the Teams window instead of your slide deck.
Okay.
To
Is
reshare.
it better now? Now can you see this?
Yeah, now it's good.
Painting by me.
Yeah.
Awesome. Okay, let's get started. So basically, you must have heard this phrase. It sounds familiar. It's rhyming with this old proverb of water everywhere, no drop to drink, right? So you are in an ocean trying to find water, but everything is salty and you can't drink anything. Well, if you see, the similar thing exists in the world of data science and trying to find insights out of data science as well. And I've tried to make it as dumbest version as possible because I myself don't understand a lot of high sophisticated things. And it boils down to stakeholders being able to understand different things. So I've tried to simple it down, and you might have to face my horrible attempt at drawing things. So let's start with a little bit of introduction. I'll not bore you up and repeat myself with the introduction that I gave earlier, just a little bit of brush up on things. I have been a CTO in my past life, product builder, and a little bit of hacker in terms of finding solutions. I'm very active with the open source community and trying to build community myself as well. And I'm mentor to a lot of kids trying to get into technology and advisor to startups and other organizations. The slides link would be available in the end, and you can even visit my website amanin.tech to get more information about the slides, or if you want to get in touch with me, these are my social media handles as well. So let's get started. I would like to start with a very interesting quote that I got to know, which was, without big data analytics, companies are blind and deaf, wandering out onto the web like deer on a freeway, right? So a lot of companies talk about data science, blah, blah, blah. But if you don't know what you want to do with it, it's just spending and burning a lot of millions of dollars in just people trying to save their asses or people trying to save their jobs, but not able to accomplish something. And that what's actually gave me this important question. Hey, what's even the difference between data and insight, right? So a lot of people talk about data is everything that we see around, like bunch of zeros and ones and different logs and telematic data. But the insight, what basically is it, and how can I drive decisions out of these insights? So how I understood personally from one of my professor, Dr. Dimitri Sacharidis of TUVN, that see, data is like this huge ocean of information, bits and pieces floating around, and you are like a person sailing this boat, right? Now, insight is basically if you use proper tools, data science algorithms and analytics, and different BI engines and all. We'll talk about that in the sessions as well. What you get as actionable items and decisions out of this data is actually what insights are. So almost like a lighthouse, which is our data analytics tool, and it's helping us find and navigate through this ocean of data. That's what basically insights are. Now, a lot of you might be already familiar with this thing, so I'll not bore you, and we'll get into a little bit of technical stuff. But I wanted this to be a very wide array of stakeholder friendly, because I think there is a huge gap between when it comes to people who know about technology and know about data science, and people who actually can make business outcomes or solutions to these problems but don't know about technology. And there is this huge divide, and that could be bridged with the help of everybody understanding and simplifying steps. And that's an attempt basically with this presentation. So we'll see what we are going to cover up in this agenda for this talk. Firstly, we'll talk about the problems and solutions in this whole paradigm of finding insights from data. Then we'll see into a new concept called as data science sprints, that is similar to product development sprint, but how you can do it in data science aspect so that you can deliver faster outcomes in shorter period of time. We'll also look at the approaches in modern day data science, which are code versus no code, and different tools that you can use in both of these things for a modern data stack. And finally, we'll see an important aspect, that is visualization, often missed out by a lot of engineers and even data analytics folks. And we'll see about like how you basically can use the power of visualization to explain things better. So let's get started. Now, this is basically the problem circle that I have discovered so far in the whole data science process. A typical data science project looks something like this. So it is divided into 5 stages. The first one is collection, where you are actually collecting data using different log streams or analytics tools or customer telematic data. And then it's the ingestion, where you are processing and feeding all this data to a single endpoint or maybe multiple endpoints. Then you're preparing this data so that you can filter out, normalize the information, remove the outliers, fill in important aspects of data, and just like pre-processing, cleaning, computing this data, providing SQL queries and running processes on top of it, and then finally presenting it. And in this entire 5 steps, that's where all these problems occur, and we'll discuss about these problems one by one. The first problem that I generally see with any of data science whole pipeline is the goal clarity, right? It's important to keep everyone aligned to the ultimate achievement and improve this overall service of providing solutions. And often I see in the teams that a data science team might often not being able to clearly define what they are actually doing. And if you go to different stakeholders, they might be arguing about, oh, we are meant to find the KPI, we are meant to find the ROI, blah, blah, blah. And ultimately, this leads to a lower ROI. You are investing a lot of heavy money and heavy dollars into the problem, but you are not able to find a solution. And the solutions to this thing, of course, is goal setting, typical 101 management thing, and also communicating, right? But we'll see through the upcoming slides in the solution aspect of it, how you can actually apply these two things in a data science sprint to make it possible. Then the second problem is poor planning, right? And the symptoms you will see is longer turnaround time. The delivery date that was expected to deliver the whole solution is actually not there yet. And often you are hearing problems like there is resource crunches in the team. Solution to this is using an iterative approach, which I also call as the sprint technique, which is similar to how we use in product management, but how you can customize it to something similar to data science and can deliver the same kind of outcomes a Scrum, Agile, or sprint methodology gives you in product development. Then dirty data, right? It's not a dirty word, it's just a dirty data, which is basically leading you to leading the whole process of providing insights out of data, whole time consuming process. If your entire data ingestion is not right, then of course there would be a lot of back and forth, and you will not be leading to a good results. That often leads to poor yield as well. So you're feeding in terabytes of data, but you are getting like nothing out of it. The solutions to this that I have personally found is something called as federated ingestion. For those of you that don't know this term, basically what federated ingestion means is that you are trying to collect the data through a single API or a single endpoint as soon as possible. So a classic example in this thing is Segment, which allows you to collect information from various sources, from web services and different things. Another service is Snowflake that helps you mainstream data from different telematic devices and data storage systems to one single stream. The advantage of this approach is that you can triage things very easily. Usually in your whole data science process, there would be different ingestion points when data is flowing from one department to another. And often these are the points where you actually can identify if the data is dirty or not at the time of your pre-processing or anything like that. So kind of harnessing and tapping on and duct taping the actual source of the flow rather than trying to put in buckets to prevent water from leaking. And another important thing as a solution is data enrichment source. And what I mean by that is often we try to correlate users persona. If the data involves something that has to do with personal identity and personal data, we often attach the identity and the user information at a very later step. I have seen data science teams doing it, but rather than that, it would be a better approach to enrich the data, add the personal information of the person directly when you are ingesting the content. What I mean by that is, let's say if your application uses login credentials, so use something like a cookie variable to store this information on the client side, and then directly your ingestion tool or analytic tool reading this data instead of post filling it in the secondary. Why it is helpful? First of all, again, very easy to triage. You can easily go to the federated ingestion source and see one by one for your own diagnosis if everything is working fine. And also it helps you with managing the compliances like GDPR or PDPA. So if a customer chooses not to track, or he chooses to delete his data immediately, then you don't need to go and find this data in the later on silos or during the post ingestion process. It can be directly disabled by just deleting the cookie or not reading the cookie at all. And even the whole session could be removed from a server side, and that is usually a easier technical way than bringing your data science team and asking them to do this GDPR removal request. So that's a very advantageous thing. Also improves in cleaning the data and helps with the compliances and privacy. That brings me down into actual technical challenges of implementing these things. And often you will see there is a lot of back and forth between the technical teams and the non-technical teams. Whole system would seem inefficient. The teams would be questioned again and again. Is this even the right project that these teams should be doing? And you will often see that there is a lot of talent shortage in my industry. For example, one of the industry I'm working with right now is insurance, and it almost runs like 10 years behind the whole banking industry. And often I see that nobody is even interested in work in the insurance sector. So that's why there is nobody who knows data science well enough and can provide us with the insights that can help them craft better products. And the solution to this is, and thanks to no code, there are a lot of no code technical solutions out there which can help us create data science without knowing a lot of technical things. And that also boils down to individuals who are actual decision maker upskilling themselves instead of asking another person or outsourcing the whole job. So kind of a more agile and independent lean structure approach, and people who are at the managerial or decision making positions, blah blah blah, they can themselves make choices if they know these tools and how to use them, and there is no need for back and forth between the teams. Complexity. You will often see that people are saying that the information that is finally brought upon as insight is hard to comprehend, right? Data science people say, oh, I have worked on numerous number of hours on creating this visual graphs and all that, but nobody is able to even understand what these graphs even means, right? So ultimately leading to poor decision making. And often people would be scared to even being called morons because they are not able to understand this data. And next time they will say, oh, let's skip the science aspect of the data science and just do the old guesswork, and the whole thing is just nothing but cherry on the cake, nothing serving any practical purpose to the whole team. Solution to this is using better BI tools, visualizations that can help comprehend the data much better, documenting the whole process so that multiple stakeholders know what is going on into the team. Last but not the least, and this is also often termed as a silo and very popular, often popularized problem in the whole data science aspect, that is people who are working in different teams don't have like visual transparency over what is going on, and often then they question and they don't trust the reliability of source and data. So often you will see poor growth accounting. You are not able to triage or use tools like KPI, OKRs, or original benchmark to account if a team is able to deliver results or not. So I mean, if every team is enabled with their own data science and they have their own independent KPIs, I think that approach would be better with a bottom-up kind of philosophy instead of a hunter going on, hey, show me these results. So data could be better accounted if we have a more non-siloed approach. And also the yield of, again, as I talked before, you are pouring in terabytes of data, but you are not getting any results. Lack of communication is also a great sign to see there is silos between the team. Solution to this, single source of truth. There are not multiple graphs or not multiple dashboards or PDFs to actually comprehend. Every process is automated, and you are heavily relying on automated technologies like dashboards, where everybody can just log in and interact with the data instead of somebody compiling these PDFs and sending out the hard copy to everybody or even the PPTs to everybody, right? Because then it's just one-way interaction. There is no feedback attached to it. There is no exploration involved in it. So that's how I think a silo problem could be dealt with. Now let's come to the interesting point. When I saw all these problems in the industry, and at the same time I was reading this book by Jake Knapp, which is called Sprint. And it's exactly the same sprint methodology that we used in product development, but they talked about how you could use the sprint methodology to test ideas faster. I took it a step further of how you can use a sprint approach in your real world data science project. I'll quickly brush upon all these 4 stages of product development and what are the different steps involved in it. So there is clear goals, plan well, execute, test, and improvise. These are the 4 stages. So first of all, you introduce the product to the stakeholders. Then you set the long-term projects that what you are actually trying to achieve. Then you break down this long-term goals into individual sprint question. And this could be even as detailed as how many people in this demographic exist. So a precise question like that can help you specifically answer while generating other insights as well. Then you go back to the team and you ask everybody in the stakeholder team that how might we do this? You've asked people to democratically choose and pick like which approach we should go with, which is the first approach to go with. And of course, all this is meant to be done within a week or 2. That's the timeline I usually take, so that there is a fast iterative process and there is enough room for you to learn instead of doing months and months of planning and then delivering nothing. Create a flow diagram so that everybody understands what's going on. Set deliverables, what are the actual achievable items, set a timeline for the project, and then meet regularly. This is the execution stage. So you're going through a 2 weeks process and you are meeting almost, you can do a daily stand-up if the process is just young and fresh. Otherwise, I think alternate days or once in a week also works perfectly well. Then finally, when the project is over, you are trying to create the MVP or the test report first, instead of just dumping out the solution project to the team. You are actually delivering them, hey, this is the actual output of it. Collect the feedbacks, document the learning, and then repeat this process, repeat the cycle, every time answering some more questions, every time giving them some more test reports to go through. And if you repeat this process, to my experience, if you repeat this almost 10 times, which is 10 sprints, 20 weeks, your entire data science team would be well enough capable to produce any kind of challenges and tackle any kind of data science problem. Now let's talk about approaches. I'm running short on time, so let me brush it up pretty quickly. So in terms of approach, we have code and no code techniques, right? So I'll not dive too deep into this, but the pros to, of course, code technique is that it's flexible, scalable to produce, but the cons are that it requires certain level of technical expertise. You should be able to write code, of course. There are silos and also speed constraints. Pros to this approach of no code and low code is that the speed to delivery is quite low. And the learning curve is also quite low. There is just drag and drop option, and mostly within a week, anybody can learn to use these tools and use it in their day-to-day life. It's collaborative as well because multiple stakeholder can come. It's not like code where you're just coding and only the outcome is receivable, but multiple people can come in and contribute of what their angle of finding an insights is. The cons of this approach is often it doesn't have that much of flexibility as compared to the code, and you are stuck with the tool, so you're dependent upon the tool. And also it's not scalable. If you are thinking of ingesting a lot of insights, then this would be pretty hard to actually maintain and follow through. So in terms of the core tools, I have found that there are three basic categories: data science programming language, Python, R, and Scala, pretty basics, and then you have to do everything on your own. Then you have querying and analysis, which is basically querying languages, which helps you produce insights or answers directly. SQL is the mother of all languages in querying. And then you have modern ones like BigQuery, which helps you do more dynamic functions. And then you have end-to-end application suite, which is a combination of programming languages, ETLs, and SQLs, and visualization as well: Apache, Spark, BigML, and Hadoop. Then on the other hand, no code, low code. I'll not go deep dive into this, but I'll be sharing the slides so you can check them out, and based on what your specific need is, you can see. So personally, I have tried PostHawk for product analytics, Data Robot for data science and machine learning, and workflow automation, Workato and Zapier. And these tools definitely save a lot of time as compared to writing code, because then there is no production kind of step involved. Whatever is working in your development work, you can just click on a button and it goes to the production. So that's also one great advantage to it. Decision making, if you are thinking about any of these two approaches, is pretty easy. If your functional requirement is high and your expected time for implementation is fast, then this is the best suited job for a no-code solution. But if it's on the other side of the matrix, then you should go with the code solution. So if you're looking at something, if your team is just starting with the data science, I would highly recommend to consider the no-code solution first, because that can help your team even test if this data science is the right kind of methodology for you or not. If the no-code things work, then you can expand the capability of your team, including some more engineers, and they can help you produce better results. Talking about visualization, again, I'll not go deep into this. I'll maybe brush up into some of the one. This is kind of a decision matrix that helps me, like what kind of data I'm trying to visualize, and based on different parameters, if it is one variable, then are they similar variables? No. Then if they are in ordered function, yes, then I can like choose which kind of visualization works best. Often because it requires extensive understanding, but this kind of metrics have always helped me in order to understand how I can visualize my data better. Again, slides link would be available, so you are free to use them in your day-to-day life. Dashboarding, things that we touched upon in the beginning, which is basically a process of collecting all the finding, organizing them in a proper way, automating the whole pipeline so that there is no publish PDF step involved, and everything is happening very automatically, and then you are sharing access with everybody. There are already a lot of tools that can do this thing out of the box, like Apache Superset, Google Looker, Apache Plotly Dash, and Amazon Quick Sites. Apache Superset and Plotly are my favorite because they are open source and free, and you can deploy it on your own server. Looker is an enterprise software, and Amazon QuickSight has a free trial version involved. So I would really encourage to go start in with Plotly if you can manage and create dashboards for your data using Plotly Dash, and then try out other solutions based on your own requirements. Then for documenting, again, to bring everyone onto the same page and logging the feedbacks and improving step. Pretty simple. I use personally Notion to collaborate all the people coming together. The whole point is, instead of doing the talking, can we do the documenting process so that everything is very well structured, and you can go back to these learning whenever you want. Add the progress as you go, add the findings, and collect feedback from the people, and go back to this document again and again in the entire journey of the sprints to see if you are making any progress or not. So a lot of things. I didn't had a lot of time. I would have loved to, explain things much more deeply, but I hope I was able to deliver something from this whole talk. To just quickly summarize, what did we saw today was set of problems that happen in day-to-day data science kind of journey, and why they are not able to produce insights. We saw solutions to this, two approaches, which is code and no code. We saw how you can do visualization, dashboarding, and documenting for your project. And finally, we see a new technique that is called sprinting in data science, and how it can help you produce results in a faster time. That was pretty much it. I'll pause here for a minute so that you have time to scan the QR code, and that would help you, get the slides if you want. And I can also put it on my social media so that you can come back later. The links is also available on my project website called as amanin.tech. And then don't forget to reach me out on my LinkedIn or Twitter if you need any more advice or want to give any feedback for the project. So now we can proudly say that data everywhere, and it's a good time to think. Thank you so much.
Thank you, Aman. Interesting session. I think it was a good overview of all the different steps that we need to undertake in a data project. But what I liked the
Right.
Oh, what I liked the most was also the overview you made with all the different tools for each step in the project. Is there that diagram? It's part of your material that is available for everyone.
Yeah. So this whole thing is made in a tool called as Miro. It's a tool that I extensively use for diagrams, and then anybody can go and see all this tool zooming in, zooming out the way they want to interact. Yeah.
Tool I have not heard about, so I'll have a look at it because it looked nice and.
You said mural, right?
Yeah. Sure.
Ah, Mural. Okay.
Yeah.
Yeah,
Miro,
yeah.
M-I-R-O.
Yeah. Okay.
Yeah. Again, the code will give you the access directly to the dashboard, which is actually the tool, and then you can even drop me comments, and then we can collaborate and make this approach better.
Okay.
Nice.
Cool.
Yeah.
We did not get any questions in the meanwhile from the audience, but means everything was explained well. We can only thank you for your presentation. And,
thank you so much.
Wish you all the best in your entrepreneurship and the startups that you're starting. And hope to hear more from you.
Yeah, don't worry, it happens to me a lot as well.
All right, Aman, take care and enjoy the rest of your day.
Thank you so much.
Bye.
Bye-bye.
You too. Bye-bye, guys.
And that brings us to the end of another session, and we will see you back in a couple of minutes for the next session.
Yes, it's going to be fun, right? We have a live.
We have a live
from
speaker
the studio
right here. Big surprise. You will see who it is.
See you in a bit.
See you.